Hello, everyone. Thank you for joining us for a bonus session in our Climate Action webinar series. I'm Rona Rothenberg, AIA California First VP President-elect, and I'll be your moderator for today's segment. As you know, AIA California has developed an in-depth series focused on understanding and implementing the AIA's framework for design excellence. The series will run through the end of the year and feature monthly hour-long general climate action webinars, as well as a 90-minute webinars that dive into technical topics. Additionally, AIA California has partnered with various organizations with like-minded goals to bring bonus content to you in the comfort of your own office, wherever you are. As always, all the content and additional resources will be available on our website shortly after each session. A few quick housekeeping reminders. Today's session qualifies for one AIA Health and Welfare Learning Unit for those watching live, and staff will report these for you, and it's being recorded. We will post it up in our website with additional resources and a PDF shortly after we finish. As a reminder, please use the Q&A function. Hillary Crack, our capable staff, senior staff, and I will follow the questions when we get to the end. And if we don't get to all the questions, we will try to respond to those and post them up in our postings. On to the webinar. We all know that reuse of existing buildings is a great strategy for conservation of embodied energy and carbon. Historic preservation can serve as a model for identifying avoided carbon impacts through improved building use and adaptive reuse. New digital tools are emerging that allow for calculation of embodied carbon in support of adaptive reuse projects. In this presentation, our expert speakers will explore strategies and methods for calculating and comparing the energy carbon dioxide emitted for building treatment options in support of the framework for design excellence. So I'm going to turn the presentation over to today's presenter, John Lesak, AIA, FAPT. I have a long bio for you, John, but I think I'm going to let you introduce yourself and speak in your own words about your very substantial background and a special knowledge. And then when we come to the end of the presentation, we'll do Q&A, and then we'll close promptly before 1 o'clock. So with that, I pass the floor to John. Thank you.
Thank you, Rona. Can someone confirm that the slide shows up?
You're good.
Okay, thanks. So welcome everybody. I'm John Lesak. I'm a principal with Page and Turnbull. That's my day job. I have other things that I do. I teach a course in historic preservation and sustainability within the Heritage Conservation program at USC under the School of Architecture. And then I live in South Pasadena. I'm a South Pasadena Planning Commissioner. I also am a board member for Preservation Action. That's a nonprofit group that lobbies federally for funding and changes in legislation that are in favor of historic preservation. Today, I am going to talk about historic preservation and how building reuse relates to the concept of embodied energy and embodied carbon. I'm a historic preservation guy. I have a background in structural engineering. I have a degree from the University of Illinois, Champaign-Urbana, both Bachelor's of Science in Architecture and Master's in Architecture. I worked a number of years, and I tend to bridge the gap a little bit between building science and historic preservation. When I think of buildings, it's really the most environmentally, building is the most environmentally impactful thing that people do, both constructing buildings and operating them. But when I think about a existing building, I like to think of it as a piggy bank that we've been investing energy or carbon dioxide resources in over time. And, the thought of taking that piggy bank and throwing it away or demolishing a building, gives me heartburn. I tend to frame things as thinking about this is a resource that's all, existing buildings are resources that are already established. How can we make the highest and best use of them? So today we've covered the welcome and the introduction. I'm going to do a quick historic preservation 101 for folks in the audience who aren't as familiar with historic preservation. I'm going to talk about the built environment and types of energy, how embodied energy and carbon relates to that, and then looking at sources of data and new tools that are emerging, and then some thoughts on embodied carbon. I tend to think of it as embodied energy. I've been looking at embodied energy since at least 20 years, and I think that way, although I'm starting to get my mentality shifted to thinking more about carbon dioxide. So a quick briefing on historic preservation. There's really three fundamental things that a place needs to be considered historic. The first is a historic context. So a building or property needs to fit within the broad patterns of history. The next is significance. So the property needs to be significant within that historic context. And then the last is integrity. The property needs to have certain elements that physically convey that the building is significant within its historic context. And these things break down into different categories. So historic contexts tend to be organized around themes. There can be lots of different themes. Obviously, architecture and design is an important theme, but something could be, historic because of its contribution to the entertainment industry, or to politics, or to policy, or to social justice. A historic context works in and around a place, and it has a time period, or a period of significance. And then historic significance, also has different categories. So something can be historic for its association with a famous event. It could be significant for its association with a historic person, or a person who's notable for their influence on history. It can be notable for as a work of a master designer or architect. It can be a special example of a type or style or type of property. So, it could be a specialized factory. And then it can be significant for things that it can tell us about prehistory. So I think about it more as archaeology, things that might not be recorded but exist there and can inform our understanding of the past. And the last one is historic integrity. So historic integrity breaks down into different categories. There's a photographer that we work with who's come up with a good acronym, MADFLAWS, to remember these things. But the materials, the actual physical stuff that a building is built with, its design characteristics. One that's more nebulous is feeling. Does it, if something is a historic airplane hangar, does it still feel like a historic airplane hangar? Locations, buildings move around a lot. I've been involved in relocating several buildings. So, is it still in its location, or does its current location have the appropriate relationships that, the property was known for? Association has to do more with the events and the people, but also design. Can you feel that link to that event or person? Workmanship or craftsmanship is the effort that goes into manufacturing all the pieces and assembling them into a building. And then the last is setting. Is the building still in a physical environment or site that helps you understand its historic significance. And the historic integrity pieces really start to translate into what do we preserve when we're thinking about a building. So we, as a firm, we look at character defining features and significant spaces, which are the architectural components, pieces, parts, which establish a visual character of the property. And then we can have significant spaces or important spaces that help us understand the nature of the property. And sometimes that's a sequence of spaces. I always use the analogy of a historic theater. You come in off the street, there's often a ticket booth, and you go in and there's a lobby and you can get your snacks, and you typically go through a little vestibule and you enter into the theater. And that sequence is something that you'd want to preserve when you're looking at updating or restoring or reusing a property. Next is how do we treat a historic property? So there's different classifications within the Secretary of the Interior standards, which is kind of the big guidance that we follow when we're deciding how to craft a project. The first one is preservation, which is really taking steps to keep property the way it is. It's kind of the lowest impact, least effort. The contrary to that is typically a restoration, where we're taking a property back to a specific period in time, to that period of significance. And sometimes that can involve removing or demolishing parts of a building that are not contributing to the significance, and reconstructing things that might be missing. Reconstruction is a special one in case a historic resource or property is lost. It can be lost through a disaster, kind of unauthorized demolition, a whole variety of things, but allows us to, this is the standard that informs us and guides us in rebuilding something. And the last one, and most common for our practice at Page and Turnbull, is rehabilitation, where we're looking to preserve the historic character of the building while still either introducing a new use and adaptive reuse, or upgrading the use to contemporary standards. And this is what I call the abridged version of the standards for rehabilitation. And there's 10 properties. I'm not going to go into too much, but the ones I've highlighted really are about saving material, preserving kind of construction, and those parts of integrity that exist. So inherent within historic preservation is really keeping materials, finishes, construction techniques that define the building and characterize the building. So it's inherently one of these things where we want to keep stuff within that building piggy bank. And that's where we start to get into the concept of embodied energy and embodied carbon. And I'm sure most of you know this, but there's when we think about the built environment, there's different buckets, I like to say. So there's operating energy, which I feel like has been really well talked about and discussed in our march to kind of getting carbon neutral. But there's also embodied energy, which is the energy which is required to produce a building. It's kind of that upfront investment of natural resources, manufacturing, transportation that goes into building a building. And then there's transportation energy, that's getting people to and from different parts. And I add a little one called demolition energy, because to demolish a building, there's energy and carbon dioxide emissions that go into that as well. So this is a little pie chart from U.S. Energy, and it just talks about consumption by sectors. This is back from 2019. The operation of commercial and residential building, is still around 40%. It's going down, which is a good trend, and we would expect it would go down. But there's also energy that goes into the industrial sector, and a chunk of that, at least a third, has to deal with constructing buildings and components of buildings. And then transportation, again, this to and from. So as time goes on, we're seeing these chunks, building operation, kind of manufacturing and industry and transportation, starting to be closer and closer to a third, a third, and a third. And Architecture 2030 has a graphic also that just looks at kind of CO2 emissions by sector, and building operations is still a good chunk. Transportation is still a good chunk, but the building and building materials and construction, the active building of building, is 11% of global CO2 emissions. And as we get more efficient in our building operations and we get more efficient in our transportation, that pie wedge just grows and grows and grows. So I'm going to give you some background on embodied energy. It's been around for a while. In 1976, a study was published that really started to look at energy use for building construction. And the main reason why I show this slide is one of the guys that developed this is also an alum of the University of Illinois. So I'm proud of our university and program there. But these guys started to really take a look at what is the energy investment that goes in? The energy crisis was upon us, and there was this idea, hey, we put a lot of effort and resources into building buildings, and can we quantify it? And they started to look at these things, and there's types of embodied energy. So there's this initial input that we put in. Some of it is kind of direct, meaning it's the transportation and construction process, and some of it's indirect. It's kind of the effort to acquire, process, and manufacture building components. And then there's recurring. So there's always, you're going to renovate buildings periodically. There's effort that goes into maintaining buildings, and that's kind of a recurring energy. So that's always putting the coins in the piggy bank, so to speak. So these guys spent a lot of time, did a lot of research, and collected a good amount of information. But as they started to kind of plug the information into primitive models, they were starting to see, hey, this is actually pretty complicated stuff. It's not easy to do. And they came up with different ways of modeling the embodied energy. So they had a real simple concept model, which is my favorite right now, because I don't have as much time as I used to kind of run scenarios. But the concept model is really just based on square footage and according to a building type. There's also a survey model. So let me go back a slide. When we're looking at initial embodied energy, you have, roughly 24% for the building structure. You have about roughly 26% for the envelope. Services are mechanical, electrical, plumbing, fire and life safety. That's also roughly a quarter. And then the rest is involved with kind of site work, the finishes, and the construction. So roughly half of the investment is in your building structure and ship. And that's kind of what they were finding, and what they added into the survey model is this survey of primary architectural materials, mostly structure, systems, and enclosure. And then if you really wanted to get into the weeds, you could do a detailed survey of all the buildings. And they spent time kind of with early life cycle assessment type mechanics to collect information about, you know, what goes into building, you know, all the different various building materials. So this is, you know, a chart from their publication, Energy Used for Building Construction. And here's kind of just a simplified version. They were measuring everything in British thermal units, which is starting to be a little bit outdated. I kind of threw it into kilowatt hours and megajoules, but they identified early kind of one of the complexities of this is what's the functional unit that you're going to use for all these different things. In the case of lumber, they ended up with board feet. In the case of steel, it was by the pound. In the case of concrete, it was by the cubic yard. So you have added layers of complexity with all these different units and all these different measurements. But they also developed this concept model, which is just kind of what's the investment per square foot. So they, you know, they determined that for a typical residential property, you know, it's about 700,000 British thermal units per square foot. And that's the single family home. There's some other ones on the screen. So around the same time, we were in the midst of the energy crisis, and there was a real push to, you know, tear down historic buildings because they were energy hogs. They were not, you know, they were perceived to not be efficient, and you know you know, they were being demolished in favor of more efficient buildings. Which, ironically, if you look at the, you know, data from the 80s, the 80s were kind of the worst for building operations. But the National Trust for Historic Preservation kind of saw this and decided to focus on the concept of embodied energy as a preservation strategy. So on the right is the poster from the National Trust annual conference, where they talked about reusing America's energy in the form of buildings. And they also did a publication, which was New Energy from Old Buildings, which had articles and applications for how to use embodied energy as a strategy for compelling people to save buildings. So Booz Allen Hamilton and Associates were the group that put together the publication, and you know, they were looking at assessing energy conservation benefits and historic preservation. And they kind of came up with a tool which is really avoided impact analysis. So looking at the time required for a new building to operate before it caught up with the investment that existed in the building. For my class and for some of the groups, we put together a little analysis. So this is the Marin Center for Chicano Art and Culture in Riverside, and it's an adaptive reuse of the old main library. And it gave us kind of a good example. On the bottom right is the new library that should be opening any day now as they lift COVID restrictions. And on the right is the old main library. This is a picture from the phone book from the cover of the phone book from Riverside in 1961. But an example is, you know, if we use the concept model, how many years of operation would a new energy efficient library building need to operate to recoup the embodied energy invested in the construction? And then there's a bunch of data, and I'll send, you'll get a copy of this afterwards, and you can go through it. The scenario also had an upgrade for the the old library. So there's investment there. But you can see in the graph, the orange line is the existing building and the blue line is the new building. At the base, at the year zero, we have the embodied energy investment. This is in the new building. We don't have as much in the old building. The old building's not as efficient as the new. And as they operate over time, there's a crossing point where they're equal, and then the new building takes over. But that's a long time period. That's, 25, 26 years. We need to see some of these savings immediately. There's pressure. So, can we wait? The argument is, can you wait 25 years to really see those savings? Most folks at this time would say no. So this is the strategy that was being implemented in the historic preservation community, really in response to the energy crisis in the 1970s. And then the trust, updated this thought process in 2010 when they did a publication called The Greenest Building. I hope most of you heard The Greenest Building is the one that's already built. But they did a life cycle assessment of a variety of historic buildings and compared to new baseline buildings, and took a look at what savings were there, and it was a pretty robust study. They took a look at 6 different types of buildings. They did it in a wide variety of environments: Portland, Chicago, Atlanta, and Phoenix. They took a look at energy efficiency measures, kind of doing base case, advanced case, and the initial. And they looked at the impact categories of climate change, aquatic acidification, aquatic eutrophication, ecosystem quality, human health, and resource depletion, and all those categories had a bunch of subcategories. But their key findings were that building reuse almost always yielded fewer environmental impacts than new construction. The one category that really didn't work as well, which is kind of ironic, is conversion of industrial or warehouse buildings into residential apartments or condominiums was the one case where you tended to invest more resources in the adaptive reuse than than just building new. But buildings with average level of energy performance consistently offered immediate climate change savings, climate change impact, and that's that delta that I showed you when I did the quick avoided impacts analysis. And then materials matter, so that's feels like a no-brainer, but the quantity and the type of materials that you use, even in a rehabilitation project, can radically affect the findings that are there. Just realized that one's out of place, so I'm going to skip that one. But around that same time, the climate crisis was really starting to be much better understood, and there was a shift in thinking from embodied energy to embodied carbon, with looking at the sum of the greenhouse gas emissions that go into the same types of processes that that the embodied energy folks were looking at, extraction, manufacture, transporting materials back and forth, use and maintenance, and the like. So that materials matter piece becomes important to us in the historic preservation world if we're trying to kind of manage the impact of our reuse projects. And again, depending on what new materials we select, is there. There's published information. Architecture 2030 talks about, there's a savings of 50 to 75% reusing the building. And a lot of that goes back to the structure, site work, and envelope. So the baseline information for a variety of different tools, things always come back to the environmental product declarations. I think people in code, a lot of people will be familiar with these, but I'm finding a lot of people are not. So it's really about this process where we have product category rules, which are the rules of the road for doing life cycle assessment for a very wide variety of materials. This particular process has third-party verification, but you kind of set up the rules, you do your assessments, and then you publish your data. And the published data is really the environmental product declaration. One of the things that I have trouble with is finding information on brick and clay tile and that sort of thing. The ESTM is one of the third-party reviewers that exist out there, and they publish some product categories, and this is one for brick and clay tile. It expires this year, so I'm hoping it'll get done, but I'm still having a struggle finding EPDs for brick. And then this is just concrete block, just as an example of a EPD. So the category rules are defined by international standards, ISO 1425, and it really sets up the framework for what you're going to report. This is an example of a table of contents. One of the things I always struggle with are functional units, and figuring out what the functional units are. It also looks at system boundaries, which I'll show in a second, kind of units and quantities for reporting, what the calculation requirements are and what the parameters that you report are. And the system boundaries, this is, going from materials acquisition to production to distribution, all the way through. This one is actually for furniture, and it has the mandatory reporting omits kind of the service life and demolition, but in this case, it also omits the materials extraction, which I think is a bit limiting. This is a little bit better graphic. This is from the Carbon Leadership Forum, and the blue pieces are these are the different stages. So there's the production, manufacturing stage, use stage, and end of life stage. But there's they are mandated to report the extraction and upstream production, the transportation to the factory, and the resources that go and outputs that go into manufacturing, but they don't really report the transportation to the construction site. And we can start to get, further, we frequently get material from pretty far away. The installation, the use may be reported, may not, kind of all the maintenance stuff typically isn't reported. You may do the transportation if the material is demoed, and the waste processing, you may not. So they do vary quite a bit. And then this is just an example of a product declaration, and again, ISO standards, and then there's reporting. LEED a few years ago adopted this in part of their materials and resources category to take a look at the EPDs and assess the impacts of the various materials. And this is a example from Drive It, exterior insulated finishing system. But I always struggle with the system boundaries piece, and MND means it's not included. So the use stage isn't included, and then several parts of the end of life stages aren't included, and that's there's reasons to not do that, but still, I don't think you're getting the whole picture. But the great thing about the EPDs is that they do kind of publish global warming potential in the form of carbon dioxide equivalent emissions. So this is kind of the information that fuels all the various online modeling and pieces parts if we're really looking to start to craft robust models for looking at CO2, embodied CO2 in our projects. They also look at energy that goes into the production as well, both from renewable sources and non-renewable sources. So I find that information interesting as well. So there's several different, there's a couple different programs that allow for comparison of EPDs or environmental output. The one that I've used the most is bees. Unfortunately, version 1 has gotten a little bit old. I like version 1. It was fairly robust and had things like brick and clay tile in the database that I could use. But BEES is the Building for Environmental and Economic Sustainability online tool, and it is by NIST, the National Institute of Standards and Technology. Free software, and I've been using this to compare things for a while. Like I said, I tended to use 2, but it's gotten older. Anyway, this is some of the output from BEES. It's got the similar categories from life cycle analysis, but it's got the global warming potential, so I can compare. This is for concrete, and it's allowing me to compare different types of concrete construction. And here's I like it. One of the reasons I like BEES is it shows me the different parts that go into the analysis. So transportation to installation, they're all kind of color coded. The installation's not included, but some of the things are. And that gives you kind of different, I can look at just regular Portland cement versus various things of fly ash versus various different things of slag, and start to make selections based on in this case global warming potential. I also pulled the graph for this for kind of non-renewable energy that's involved with making as well, again because I'm more of an embodied energy buff. They used to actually just show the embodied energy information. It's kind of shifted to more like this, but this is I find this a very effective tool for comparing different materials and properties. Another tool that's out there is the EC3 calculator. This one's a little bit newer to me, but allows you to make selections and has a similar type of comparison output. Another one which I have in the reference section at the end of the slideshow, but didn't do a slide for, the Athena Institute in Canada has some comparison tools too that allow you to look back and forth on things. And we're starting to see whole building models that are emerging as well. So I think that there's different ways of looking at this. Again, EC3 has a whole building model. I've been playing around with the cheats to get a whole building effect. I've still found it easier to just pull the information out of EPDs and calculate things, but we're working internally on developing Revit models building information management models that will calculate the different components so I get a bigger picture. I know there's several different types of models out there. This is the one I'm most familiar with. So I wanted to share a few thoughts in wrapping it up. So there's kind of still a data lag when we go to look for, particularly, I like to try to compare, historic materials and what may have been invested in them versus new materials. And a lot of the things that we might be looking at, particularly like brick or clay tile roofing, a lot of the kind of sheet metals and other components just don't have information. So there's a gap, and we have to make a lot of assumptions when we're looking at things. The last kind of big image I showed was a Spanish colonial style gymnasium that we reused as a student center, and in trying to run the models, we just didn't have enough information about steel windows and clay tile roofs to get a great picture. So quantifying the materials is the easy part. The hard part is finding the industry data. It's getting better. There's databases that are starting to be out there. This is a quick sheet which summarizes the information. Canon was putting this together in concert with some other groups, and I think it's a helpful tool for summarizing and making things a little bit simpler. Our big thing is that still a huge chunk of the embodied energy or carbon within a building that we're using is from structure and envelope. So the more that we can work to preserve those things and add to them as opposed to demolishing them, the better outcomes we're going to have as far as kind of total CO2. We still, the concept model would be great to apply for, and use as a quick tool in the planning stages. And we still need more benchmarking studies and information. We end up going really fast to very complicated models that take a lot of time and investment to put together. And then, more historic building cases are also needed. I'm starting to work internally at Page and Turnbull to start to benchmark our projects and publish them so we understand. And again, this kind of the historic materials is very complicated to understand, so we're always having to find contemporary analogs for them. This is a benchmarking study from the Carbon Leadership Forum. They were the ones who also did the quick EPD. It's a global study, but it's really looking at the embodied carbon, and it's interesting. You can toggle and do really the whole building analysis or just the structure and envelope. And it's a global study, but I think it was helpful. It was interesting. I tried to run some conversions and put it in terms of Booz and Allen's work and compare apples to apples. And I was finding that kind of contemporary construction is considerably less carbon energy intensive than it was in the 1970s, as we hope it should be. But it was, I still wasn't totally confident in the numbers I was getting. And then there's a bunch of resources to the information that I presented today. So that's it. I think I'm on time, which is rare for me.
Thank you very much, John. That was great. I'm not a technical expert, but I always learn something. It occurred to me that all of the reach codes that are the all electric and the gas moratorium related reach codes for new construction, many of them are going to be extended to existing construction and
Right.
will be greatly informed by some of the conclusions that you have summarized here. So we have two questions in the, we have a few minutes. We have two questions
Sure.
in the Q&A, and I'll just read them. I don't know if you can see them. One from Margaret Chandler. Did the EUI chart for existing versus new buildings indicate that a new building will emit equal to and then less than an existing building by the 27.5-year mark? This seems like a pretty reasonable return on investment period for the ideal lifespan of a building.
Well, yeah, I mean, the emissions, this is kind of a more of an, I'm assuming it was the chart that I showed for the avoided impacts. And I'm not, I think that's the right one, but there's another chart in there as well. But the new building, starts off at a loss because of the construction, but then it's doing less, it's emitting less over time. The retrofitted building was emitting more, but still it takes time to recover that offset. And then you can start to play, you can do net zero. Both, we've been, one of the images I showed was a project we did with EHDD at the Exploratorium in San Francisco. And, we've been targeting net zero energy for that building for a long time. So we can do net zero new construction, we can do net zero historic preservation. But I was working more on averages. But, 25 years, maybe it's reasonable, maybe it's not. If we're shooting to have things by 2050, that gets tricky. But I agree with you, 25 years.
Right, but I'll just offer.
Isn't terrible.
I'll
Some
just,
of the other,
yeah.
Go ahead. So.
I'm sorry to interrupt. I'll just offer in relation to her question that when the architect is working for the owner like I have, and you're trying to convince non-technical people that they should make the first cost investment, it's sometimes hard to quantify the environmental benefits that go beyond just dollars and cents. When you talk about ROI, financial decision makers are really just thinking mostly about dollars and cents, and educating them about the long-term environmental benefits can be tricky, even when they're knowledgeable. So the second question from Cameron Duncan: do you find deconstruction to lessen the embodied carbon numbers when the building would otherwise be demolished? If so, any rules of thumb?
Well, when you're thinking about there haven't been great studies on this, but when you're thinking about kind of disposal impacts, waste treatment impacts, those will be left out of the, if we're disassembling something and then putting the materials back into use. But to be honest, I haven't seen, there's some data out there, but I haven't seen great data that I found applicable to the projects that we use. There's other benefits. We find that there's benefits. I like to tell people about, the endangered wood. So the old growth redwood that you would find that you might be able to harvest out of a building in deconstructing it is still frequently superior to the kind of new growth red or the newer redwood that you'll buy, because you do have, when you think about the trees and what's been harvested, it's heartwood, it's got lots of tannins in it. So, we find that when we do wood repairs that we look 20 years out and we didn't necessarily replace redwood with redwood. It's the new stuff that is getting eaten by the termites or, having mold and mildew issues. So it's, there are other benefits. I'm a big proponent of saving and reusing old growth redwood and Doug fir and that sort of thing.
Right, but again, you know, when you apply the Secretary of Interior standards, and not every historic or listed or historically important or registered landmark and meets every single standard, there are
Right.
benefits beyond the environmental. There are cultural benefits and emotional benefits to communities, and so buildings like the little courthouse that Page and Turnbull is working for the Judicial Council up in
Right.
Willows. There were many reasons that the other 48 or so historic courthouses did not get money to be upgraded, that had to do with programmatic limitations on historic buildings that cannot all be repurposed, notwithstanding environmental and other merits.
Yeah, no, it's a common question I get is, put a value to, historic fabric, and it's hard to put a dollar value to historic fabric.
Let's see. I think we got all the questions.
There's one from Ismar in the Q&A.
Let me see.
Yeah, I see it. I can read it.
Can you read it?
Yeah, there are some LCAs that are over marketed but have gaps and do not disclose all ingredients and processes. In adaptive reuse, which LCAs should we be aware of and which will need further research? I think, let me go back, since I got the slideshow open, I can go back to this graphic, which I find helpful. So in adaptive reuse, we're in California, we're often doing structural upgrades. So we do need to look at kind of the structural components, but not always. And you start to really focus in on more of kind of interior elements for kind of a less intrusive project. So, I'm always interested in the comparison of end of life and use, because, we hope that, we can get a reasonable lifetime out of contemporary materials that we're putting in an adaptive reuse. So, there are maintenance requirements, repair requirements that, we think about, because it's our mentality, always be thinking about repairing things and maintaining them. It's kind of inherent in the standards. So what are, those things tend not to be captured in life cycle analysis that's published, these EPDs. So those are things I'm always kind of conscious of. But I do like to see what's, when I'm looking at EPDs, I do like to see what's included and what's not, because frequently it's just the things in blue and dark blue, and, not the transportation to the site, installation. I don't know if anybody's, there's a great program that the AIA has where you, they give you a fellowship to go to the Stone Conference in Verona, Italy, the International Stone Conference. It's something a lot of folks in our firm have done. But you go there and you start to realize the globalization of the construction product market, and you'll quarry a block of granite in Minnesota, but then you'll ship it to China, have it cut up into pieces, and then ship it back because labor's cheaper, and it's from a dollars perspective it's less. But you think about all the transportation carbon dioxide emissions that go into that process, and it kind of makes you uncomfortable.
Mr. Chan is asking, Henry Chan, do you see legislation requiring carbon/energy costs and credits for new construction in the future? My only concern would be affordability of homes.
Well, we've seen, you're seeing kind of carbon offsets. There's a development in I'm down in Southern California near us. I don't remember the details right off the top of my head. That's, you know, been struggling to kind of meet the state's carbon emissions now. So I think there's already a few things that are out there. But I haven't seen kind of serious discussion about the impacts of actually constructing things. It's more about operations and transportation.
Actually, in housing, money is driver.
Yeah.
This is why it's so hard to build multifamily housing. And we had a conference presentation this morning. It's extremely tricky. Lori Barlow wrote a note, but it came to me as a direct message, and we have just a few more minutes. This is a long one, but I think it's a good way to wrap up. Life cycle stages. Is there a general guideline for building reuse with respect to the type of envelope starting out? For example, older existing buildings that are heavy mass with lots of windows, which work very well in a passive mode, would score better in adaptive reuse with mostly interior upgrades, materials, and systems. This approach versus the lighter construction of the post-60 structures that may need more extensive exterior renovation, such as envelope leak repair, and not as good in a passive sense. For example, sealed windows, reliance on mechanics, etc., for optimum performance. So she's asking about general guidelines. And I think that'll be our last question.
Yeah, there's, you know, there isn't things that are, well, there's some approaches that are published, but they're not heavy data driven. What we find, well, you're right. There tends not to be quite the operations impact for the larger, heavy mass, smaller windows than there is kind of the glass enclosed buildings. We frequently look, you know, we kind of go through this process, and it's a historic preservation process. It's identify the character defining features, you know, do the analysis. Can you maintain and repair them? Within that repair, we look at upgrading them. So can we keep what's there and character defining? Not everything is character defining in place, and upgrade them. So in the case of glass, you know, can we do films, window treatments, supplemental glazing, you know, other strategies rather than just ripping it all out and putting it back in? And only as a last resort do we go to the replace it. So we kind of, on every project, we try and walk through that methodology, and more part of that methodology is working with mechanical engineers to kind of model, you know, what are the, you know, operational effects of each of these decisions. And now we're starting to use the, you know, use the comparisons of different upgrade scenarios or replacement scenarios to look at the carbon dioxide emissions. But it's kind of always this step of, you know, is it okay? Can we keep it? Okay, it's not okay. How do we repair it? How do we upgrade it? And if we replace it, then how do we replace it? So and you know, there's a historic building code that allows us some leeway in energy efficiency. So
Thank
I hope
you.
that answers. I hope that answers the question.
I think it was helpful. We do have
Sure.
one more question from Mr. Wilkin, but given the time, I'll ask you to answer it offline, and we'll add that to our posting. I would thank you all for coming. Again, we will report your units, and you will find more information on our website, and our 2021 series will be shared with you via email for upcoming seminars. And thank you, John, for an excellent presentation, and all of the 102 people who joined us. We very much appreciated your involvement, and hope that you will reach your goals with some of this knowledge.
Thank you. Thank you very much.
Bye now.